A very good evening to all my dear lovely students. Good evening. How are you? Alia. How are you everybody? I hope you are enjoying life and studying also along with. Hello, good evening, Kulusum. Pinky, good evening. Namaste, Nirant. Janu, Nirant, good evening, good evening. Good, बहुत बढ़िया, बहुत अच्छे. आप कैसे हो? नमस्ते everyone. वासु, यशवंत, रंगा, साइशा, चालम, मल्लिकार्जुन राव, लक्ष्मी, पुष्पा. Very good evening, Sridevi. Hello. Yes. Lasya, good evening, Ritika. Did you all enjoy yesterday's class? Hi, Asif, hi. Did you all enjoy yesterday's class? Are you able to make the Lewis dot structures yourself now? Okay, Charit. Hi, Charit. Good evening, Rani. Chandrika. Yes. Okay. That's good. That is good. All right. Quickly, you can like the video. 150 people are there. Once the like reach to 80 to 90, we'll start our today's class. Okay. Today we'll see how to find formal charge, other ways to find the structure, the better way to find the structure. Yes, Kaviti. Yes. Good evening. I will stop the chat after some time. Quickly like the video. As soon as the likes reach 100 around, we are going to start the class. Yesterday I was absent, so you can anytime watch the video. Thank you, Nirant. Anybody who is absent can watch the video anytime. It's all saved in the live section. Okay, I'll stop the chat in some time, and then we are going to start with our class. Okay, I'll not be chit-chatting for more. Just let us wait for few more students to join so that they also do not miss the class. Okay, so we have hit 50 likes. Just 30 more we'll wait for when we'll start our class. Okay, yesterday we have, day before yesterday we have seen this, that to find Lewis dot structure, you will find TVSU. Yes, you have to make the notes. Raghav Reddy, you have to make the notes. You must make the notes. Without the notes, how will you revise? Every time you can't watch the video, no? You'll not be able to remember what I was saying during the class for the next 2 years, right? So you have to write the notes. Venkat every day has this doubt, sir, when the classes will end. Are you waiting for the free classes to end, Venkat? Okay. Till the time you are getting free classes, it's good only for you, na? Pranati, any bond where you see a arrow like this, that will be a coordinate bond. Why coordinate bonds are formed, how it is formed, will be a later part. You will study this. Okay, I have not explained what is a coordinate bond till now. Just any bond which looks like this, an arrow, will be a coordinate bond. This is a normal bond, this is a coordinate bond. This is a normal bond, this is a coordinate bond. Okay, coordinate bond is formed by unequal sharing of electron, and the normal bond will be formed by equal sharing of electron. But what is that, how to make the bonds, that will come later when you start your chapter completely. Okay, so I'll be stopping the chats for some time. Coordinate or dative both mean the same thing. Okay, both mean the same thing. You can stop the chat. Done. All right, guys. Welcome back. So TVSU we had found. From the TVSU, by following the octet and duplet rule, hydrogen will follow the duplet rule, others will follow the octet rule. We have made few structures. Structure of hydronium, structure of CO2, CH4, ammonia, structure of carbonate, nitrate, very important structure. So finally, to learn that few bonds only will have a coordinate bond. Only a few molecules are there who are going to possess a coordinate bond. Because I told you, any member who belongs to period 3, 4, 5, see, periods are like this, no? If I look at period number 1 in periodic table, period number 2, period number 3, period number 4, and so on. Periodic table looks something like this. Hydrogen is here, helium is here. Okay. Then lithium is here. Okay. After lithium, you get to beryllium. Don't draw this. You can just see here. This is boron, carbon, nitrogen, oxygen, fluorine, neon. So only these people are there who will make a coordinate bond. Okay. Only these people are there who will make the coordinate bond ever. If any coordinate bond is there, only these people will make with the oxygen. Like in nitrate, like in ozone. Okay, in other cases there will be no coordinate bond. Means when you take aluminium, when you take silicon, when you take phosphorus, sulfur, chlorine, they will never make coordinate bond. Okay, gallium, germanium, you don't have to learn the table. I'm just telling that these people will not make coordinate bond. These people will not make coordinate bond. Selenium, bromine. These people do not make coordinate bond with oxygen. That's all. Simple. They do not form coordinate bond with oxygen. Reason I told you yesterday that coordinate bonds always bring destability. Coordinate bonds always bring hidden charges, which we will call it as formal charge. Today we'll study how to find the formal charge also. I gave you a trick to find the formal charge. Trick for formal charge was, yesterday I told you, no? Trick for formal charge was, whenever A is coordinate to B, then A always experiences +1 charge and B always experiences -1 charge. That was the trick. Today that trick will be proved also by the formula. So these people do not form a coordinate with oxygen. They will tend to make double bonds with oxygen to make themselves and oxygen both stable. Whereas boron, carbon, nitrogen, oxygen, fluorine, they only can make coordinate bonds with oxygen. They can form coordinate bond with oxygen. Two examples, you learn this only, no? There are not many molecules like that. Nitrate, ozone, can you learn these two for me? Nitrate, NO3 minus, and ozone, O3. Learn these two. Nitrate, can you see this coordinate bond? Learn this structure now. Next time when someone asks you what is the structure of nitrate, you should know there is a coordinate bond in it. Ozone, when they ask you structure, you should know there is a coordinate bond in it. Okay. So with this, let us, I told you the story of nitrogen and story of oxygen. Story of oxygen was that whenever oxygen makes, where is the story of oxygen? This one. Whenever oxygen makes one bond, whenever that one bond is a single bond, minus charge will be visible. If that is a coordinate bond, -1 charge will be there, but it will be invisible. So whenever oxygen makes one bond, it always gets a -1 charge. And it always gets 3 lone pair. Don't forget about it. Okay. Whenever oxygen makes 2 bonds, whether one bond this side, one bond this side, or both bond this side, in that case, oxygen will be neutral, will not have any charge. And it will carry 2 lone pairs. Okay. Whenever oxygen makes 3 bonds, one here, one here, one here, whenever oxygen makes 3 bonds, it will always experience a +1 charge. It will always experience a +1 charge. That charge is visible, something like in hydronium, oxygen is making 3 bonds, +1 charge is visible. In ozone also it is experiencing +1 charge, although it is invisible. This was ozone. This was ozone, everybody. Yes or no? This was ozone. In this ozone, the oxygen which is making 3 bonds, the central oxygen, is experiencing +1. You know that. It is invisible right now. And the corner oxygen with a single bond is experiencing -1, although it is invisible. So this is how we can remember formal charge. Okay. That oxygen is not experiencing anything. This oxygen is very happy. It is neutral oxygen. It is neutral oxygen, not experiencing any charge. Now, how did we reach to these charges? And then after knowing these charges, we will fail the Lewis dot structure. So we'll study the drawbacks of Lewis dot structures. Okay, everybody? Clear to everyone? Story of oxygen is clear. 3 bonds always experience +1. 1 bond always experience -1. 2 bonds do not experience any charge. Story of nitrogen, I told you. Story of nitrogen was also simple. Whenever nitrogen makes 3 bonds, it is happy. It is very stable. Nitrogen has the ability to form 3 bonds. Whenever it makes 1 extra, it gets a +1 charge. So nitrogen making 4 bonds, like ammonium, NH4 positive, you might have seen. All of you have seen NH4 positive. Ammonium, NH4 positive, ammonium. Or I showed you NO2 positive yesterday. This was NO2 positive. So whenever nitrogen will make 4th bond, it must get a plus charge without any doubt. In nitrate also you can see. In nitrate, the charge is invisible, but it is there. So nitrogen making 4 bonds always a +1. Nitrogen making 2 bonds -1. It will not be much important for you. Nitrogen making 1 bond will be -2. It will not be important for you. Okay, nitrogen will make 3 or 4 bonds. When it makes 3, no charge. When it makes 4, +1. Okay, now let us talk about formal charge and its formula. Everybody can write down about formal charge. Okay, what do you, there is one saying, no, that apne pair pe kulhadi marna, that you yourself became the reason for your downfall. Apne pair pe kulhadi marna, we say in Hindi, no. Same way, Lewis did the same thing. He, threw X on his own foot by giving the concept of formal charge. Because due to this formal charge only his theory has failed. Otherwise, everybody was believing Lewis. Everybody was believing that all atoms would want to become like, noble gases, and they want to gain 8 electrons in their octet. But then he gave the concept of formal charge. And we found that whenever we have to follow the octet rule for people like sulfur, phosphorus, 3rd period members, whenever we have to follow octet rule for them, I showed you, we have to go for coordinate bond formation. If I say chlorine, you must follow octet rule. Then chlorine has to make 3 coordinate bonds with oxygen to keep only 8 electrons as sharing, to keep only 8 electrons around it. But because of this, chlorine will be getting +3 formal charge. So Lewis gave you the formula. To find the formal charge, use this formula. We have used that formula. We got the charge, and then we said, Lewis, are you mad? Are you mad? Chlorine is getting +3 charge and you are saying he has to follow the octet. So following the octet is not important. Charge must not be there on the central atom. Otherwise, central atom will feel very unstable. Correct? So nobody should feel positive charge. Nobody should feel negative charge. Whenever charge is compulsory, means the anion only is given, Cl4-. So one charge to has to be there, but other people should not feel these charges. Other people who do not have a charge but have invisible charge, they will be very, very unstable. So this is not good. Neither this chlorine is happy to here, nor these oxygens are happy here. This chlorine is crying actually here in the corner that I am having my +3 charge. This oxygen is also not happy. I am getting a -1 charge. This oxygen is also not happy. I am getting a -1 charge. This oxygen is also not happy. I am getting a -1 charge. That oxygen is so happy only because -1 charge so perchlorate ion has Cl4-. So these people who are getting invisible charges, they actually feel too much unstable. So that's why we will fail the Lewis octet rule and will say wherever center atom has ability to expand its octet beyond 8 electrons, it will always do that. And it will make double bonds with oxygen so that now oxygen is also happy, I am neutral. Oxygen is also happy, I am neutral. Oxygen is also happy, I am neutral. Chlorine is also happy, I am also neutral. I am not experiencing any charge. Okay. So what is the formula for formal charge and what is formal charge? Formal charge it is visible or we can say it is real or imaginary charge. It is real or imaginary. Real means the one which is visible negative charge, like ClO4 minus mein one oxygen had that minus, its formal charge is -1 only. Formal charge may be visible, formal charge may be invisible. Visible means real, imaginary means invisible. So real means visible, imaginary means invisible. It is real or imaginary charge experienced, real or imaginary charge experienced by any atom in bonded state. Bonded state means when it is inside a molecule. So any charge experienced by an atom in a molecule is called as a formal charge. What is formal charge formula? Formal charge formula is, you can learn the formula, otherwise I gave you the trick already. Okay, formula is valence electron of that atom. If you know the group number of the atom, you already know the valence electron. Like valence electron of oxygen are 6. So V minus unshared electron plus shared electron by 2. Okay, this V and U and S is not the total TVSU wala. Okay, it is for a particular atom. We will see example. V is the valence electrons of that atom. U is the unshared atoms, means lone pair electrons on that atom. S by 2 means number of bonds only. S means shared electrons by 2. When you do 2 by 2 means 1 bond, 4 by 2 means 2 bonds, like that. This is the formula. You can just see the example here. So if I check first one, formal charge on each oxygen atom in ozone. If this is the question. First thing what you will do, you will find the structure of ozone. I gave you the structure yesterday already, so I'll directly draw the structure. Structure was O, double bond O, coordinate bond O. This was the structure. Okay, this was the structure of ozone. And now I am writing the unshared electron. Oxygen with 3 bonds will have 1 lone pair. Oxygen with 2 bonds will have 2 lone pairs, like this, 1 lone pair here, 1 lone pair here. And with a single bond will have 3 lone pairs, something like this. This we have already drawn yesterday. So when a question comes from formal charge, first you will do TVS, you will find the structure. After finding the structure, let me call these oxygens by different name. This oxygen is, let's say, oxygen A. This is oxygen B. This is oxygen C. Now I'll find formal charge on oxygen A. I'll find formal charge on oxygen B. I'll find formal charge on oxygen C. Okay, let us find. So although visibly there is no charge, let us see the invisible charge, if any. Oxygen A, everybody. What are the valence electron of oxygen? 6. Valence electron of oxygen are always 6 minus. How many unshared electrons do you see on the face of this oxygen? 1, 2, 3, 4, 5, 6. 6 electrons are there which are unshared for this oxygen. Plus, how many do you see in the sharing? This is 1 bond. 1 bond means 2 sharing electron. That means 2 sharing. So 2 sharing divided by 2. Simple. Again I am telling. Whenever someone is attached by 1 bond, means it has 2 sharing electrons. Whenever someone is attached by a double bond, means 4 sharing electrons. So this person in sharing has 2 electrons. Unsharing has 6 electrons. So 6 unsharing, 2 sharing, 2 by 2. So we get 6 minus 7, it is minus 1, invisible. So this oxygen is experiencing minus 1 charge, although you are not able to see it. I told you already in the trick, whenever there will be a coordinate, the receiver of the arrow will experience a minus 1. Now, oxygen B, the central oxygen. Again, valence electron of oxygen are 6 only. Valence electrons are 6 only. Minus unshared electrons. This oxygen carry 2 unshared electrons. So I'll put 2 here. Plus shared electrons. It is making 3 bonds beta. 1, 2, 3. So this bond has 2 shared electrons. This bond has 2 shared electrons. This bond has 2 shared electrons. That means in sharing, this oxygen is having 6 electrons. So 6 by 2. 6 minus 5, which is plus 1, which is also invisible. So this oxygen also has an invisible plus 1 charge. Correct? Now, formal charge on oxygen C. This is a happy oxygen, all of you know. Double bonded oxygen is the best oxygen. Why? Formal charge formula will tell you. 6 valence minus unshared electrons are 1, 2, 3, 4. 4 unshared electrons plus sharing में 1, 2, 3, 4. 4 in sharing. So 4 by 2. 4 plus 2, 6. 6 minus 6, 0. Very happy oxygen. So it is having neither any invisible charge nor any visible charge. This is the type of question you can get to find the formal charge. Now I will give you one question. I want you to solve it. Quickly write it down first. Okay, quickly write it down. Then I want you to do one question for me. Okay, if it is clear to you, just mention a clear, and then your question is find formal charge on underlined atom. Find formal charge on underlined atom. If I draw SO2 like this, you have to find the formal charge on sulfur. If I draw SO2 like this, you have to find the formal charge on sulfur. Okay, find the formal charge on sulfur, find the formal charge on sulfur, find the formal charge on carbonate, carbon on the carbonate. And this one more I am drawing, N double bond N. Overall charge is -1 here. You have to tell me the formal charge on all 3 nitrogens. This is called as azide ion beta. Okay, this is called as azide, N3 negative. It is called N3 -1. N at the foot 3 -1. This is called as azide ion. Okay, remember it is an important example. They can ask you azide ion. So azide, all 3 nitrogens formal charge, you tell me quickly. So you will answer me like this. You will answer me like this. A -1 plus 1, whatever. B -1 plus 1, 0. C -1 plus 1, 0. And D, properly you will answer it. Okay, I'll open the chat box. You can quickly answer me what is the formal charge on sulfur on A, B, carbon on C, and nitrogens on D. Quickly answer me. Within one message you have to answer. Only type a single message, write like this: A 0, something like that. B +1, C +1, D -1, 0 plus 1, -1, -1 plus 1, like that. Okay, quickly do. But do carefully. In a single message you answer. Beta, how sulfur is getting -1? Reshma. B0, good, Lakshmi. How, Lakshmi, sulfur is getting -1 beta? Sulfur pe I am asking, not on the oxygen. Are you doing correctly or not? How A is -1? Why are we doing this mistake? How A is -1? Oh ho ho. What are you doing? How A is -1, bhai? All of you are doing same mistake. Yes, A is +1, Ramcharan. Ramcharan only is smart among you. Others are all... A is +1. Oh ho ho. Why you are saying -1? A is +1. Use the formula carefully, na beta. A is this only, na. Sulfur means central person, this one. A +1. Or use the trick. No, I told you trick already. Whenever a coordinate is going, from where the coordinate starts, +1 will come. So A is +1. A is +1. B is 0. Yes, B is 0. You can't see any visible charge. You can't see a coordinate bond. So it has to be 0. B is 0. What about C? Carbonate pe carbon pe how much charge? In carbonate, on carbon, how much formal charge? You can tell me about C. C -2. C is 0. Yes, Venkat is correct. C is 0. C is not -1. C will be 0. Did you draw the structure of carbonate? How will you know the formal charge without drawing the structure, everybody? Without drawing the structure, everybody, how will you know the formal charge? You have to draw the structure, no? You have to draw the structure. Without structure, how you will do formal charge? For carbonate, how you will have to attempt the question? CO3 2- formal charge on carbon I am asking. First thing you will do, TVSU. T, 4 people, 4 8s are 32. V, valence electron. TVSU. Total 4 people, 8 8, 32. Valence, carbon 4, 3 oxygen, 6 6 6. 2 extra charge because of -2. 24. S, 32 - 24. 8. And U, 24 - 8, 16. 16 unshared, 8 shared. Carbon in the middle, 3 oxygens on the side. 8 sharing electron. You take one bond. 1 2 3 4 5 6. You take one more. 7 8. Carbon says, I am happy, my octet is complete. Do not provide me any extra electrons. Then give unshared electron only to oxygen. 1 2 3 4 5 6. I am happy. 7 8 9 10 11 12. I am happy. 13 14 15 16. I am happy. All 3 oxygens are also satisfied. Then I told you this is sufficient to draw. Now you can just find the formal charges. Okay, formal charges you can find from here. This oxygen will get -1 visible only because -2 charge so I have to give. I will give this single bonded oxygen -1. I will give this single bonded oxygen -1. This oxygen will get 0. So formal charge on this central carbon. Formal charge on this central carbon will be valence electron 4. Valence electron 4. Yes, you have got correct, Venkat, Devarya. Formal charge, valence electrons 4 minus Unshared 0. Unshared 0. Plus sharing में 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 in sharing. 8 by 2. 4 minus 4. 0. Carbon carries 0 charge here. Carbon carries 0 charge here. Is this clear to everybody? Quickly tell me. If it is clear, quickly write crystal clear and like the video. Those who have not liked the video, 260 students are there. Only 97 are liking the class. Others are not understanding or what? Others are not understanding or what? Clear na? Yes. Good. Okay. Last one is -1, +1, -1. Clap for yourself. Likes are 101. Good. Clap, clap. Some 108. Good. Some of you will take revenge, sir. I'll dislike again. I'll take my like back. Don't do that. Sir, why 0 unshared electron? Beta, where is the shared electron, Raghav? On C, where is the shared electron? Unshared electron. Raghav, on carbon, where is the lone pair? There is no lone pair, no. Carbon has no unshared electron. Carbon has only bonds. This is carbonate, according to this. O minus, double bond O. Where is the lone pair on the carbon? So there is no unshared electron. Yes. Last one is azide. -1, +1, -1 you should get. Or directly I told you, na, trick, story of nitrogen. Whenever nitrogen will make 2 bonds, it must get a -1 charge. Whenever nitrogen make 4 bonds, it must get a +1 charge. Whenever nitrogen make 2 bonds, it must get a -1 charge. Or you can use the formula. You can use the formula. Use the formula. Azide. You can see here azide. If I draw azide, this was azide. N, double bond N, double bond N. Or you can draw it yourself. Okay, let's say you don't know that I have given the structure. I might give you just N3 negative. Then you first draw it. Azide. Question can be, what are the formal charges on each nitrogen in azide? Lucky is bored. Tell to Lucky what should Lucky do. Lucky alone. Why you are alone, Lucky? I am with you, no? Consider me like your friend. Don't be alone. Don't be bored. Join commerce. Join arts. Then you will not be bored. Commerce and arts are very interesting. Science is boring only, beta. You know? Chemistry very boring. Is chemistry boring? What do you say, everybody? Let's first talk to Lucky. Lucky is very bored. Is chemistry boring? Huh? Boring or interesting? Write in the chat box. I'll come to know. I'll come and hit you those who write boring here. Okay. N3 minus TVSU. TVSU. Total. 3 people, total 24. Valence. Good. Now, Lucky, how are you now? Feeling boring or good? Yashwant also feels. You should take a better subject then. Yashwant and Lucky. I'll talk to them. You please take, home science. Learn how to make dosa, how to make idli. Learn to make dosa, idli. All those will be very, very important for you then. Okay. If you don't do chemistry, if you don't do physics, if you don't do biology. Okay. So, valence electrons, 3 nitrogens, 3 times 5, 15. And 1 extra, 16. Sharing, 24 minus 16, 8 sharing. 16 minus 8, 8 unshared. 3 nitrogens. I can write it as NN2 minus, okay? I can write it as NN2 minus, means 1 nitrogen in the middle, 2 nitrogen on the sides. Start giving shared electrons. 8. You take 2, 1, 2. You take 2, 3, 4. You take 2 more, 7, 5, 6, 7, 8. Central nitrogen says, I am too happy. Central nitrogen says, I am too happy. Then don't give any unpaired electron to the central. Give to others. 1, 2, 3, 4. I am happy. 5, 6, 7, 8. I am happy. This is the structure of azide beta. So what you have got here is N, double bond N, double bond N. And I told you the story of nitrogen. So don't forget the story of nitrogen. Whenever nitrogen make 4 bonds, there must be a plus charge. Whenever nitrogen make 2 bonds, -1. Here also -1. So overall charge is -1 here. This is azide. Okay, you can stop the chat again. This is azide. This is about formal charge. Now we'll talk about stability versus formal charge. Okay, stability versus formal charge. Write down the last point. Stability versus formal charge. So formal charge is inversely proportional to stability. Formal charges are inversely proportional to stability of molecule or stability of structure, you can say. So any structure which has more formal charge will be a poor structure. Any structure which will have more formal charge will be a poor structure, inversely proportional. More the charge is, bad the stability. I told you yesterday also. So when I look at example of something like SO3, we do the structure of SO3 by following the octet rule. This was the structure of SO3 we got. If I give you that other structure of SO3 may look like this. If S says okay, one oxygen I will satisfy you, other oxygen I will give you coordinate only. And one more structure is given to you for SO3 which looks like this, double bond. Okay, so we can see here that this sulfur will be experiencing +1 due to this coordinate, +1 due to this coordinate, and this sulfur is experiencing +2 charge. So this structure is a very, very bad structure, unstable structure. Although octet rule is followed here, sulfur is totally having 8 electrons around it, octet rule is followed, but the structure is very, very unstable. Here sulfur will be experiencing +1 because of this coordinate bond. So somewhat better. Sulfur says, still I am not the happiest. Still I am not the happiest. Try to make me more stable. Okay, to make me more stable, let us make double bond with this oxygen also. Now this sulfur is very, very happy. So this is the correct structure of SO3. This is the most stable, means correct structure of SO3. This is most stable structure of SO3. So as a note point, what I told you yesterday, we will write that in order to gain stability, elements of period 3 and above, bracket you can write the example, sulfur, phosphorus, chlorine, bromine, etc. Elements of third period and above do not form coordinate bond with oxygen. Do not form coordinate bond with oxygen, but they expand their octet. By making double bond with oxygen and do not follow octet rule. And do not follow octet rule. This is the major problem. So I told you that Lewis was the only reason why his theory failed. Lewis only gave you the concept of formal charge, and by using that formal charge as the X, we cut the leg of Lewis only. That you only gave the formal charge concept, and because of your formal charge only, the structures are not following the octet rule. So the octet rule is no longer valid. Okay, octet rule is no longer valid. Tomorrow we will write the different exceptions of octet rule, means what are the drawbacks of octet rule, where the octet rule is not followed. Mostly octet rule is not followed by these people. Sulfur, phosphorus, chlorine, bromine. They'll make many compounds where the number of bonds of sulfur, phosphorus will be more than 4. Like SF6, PCl5. I'm sure you must have heard of these molecules before. IF7, okay, CLF3, BRF5. Or in all these molecules, and xenon will also start making compounds, we'll see tomorrow. XeO3, XeO4, XeF6, XeF7, negative. All these type of compounds we will be studying in the next class. You can start the chat once. Okay, so that is all. Up to here we'll keep today. I hope you all enjoyed, and please kindly revise all these concepts by tomorrow's class. Tomorrow I'll tell you one more way to draw the perfect structure. Till now we have not reached to the perfect structure because till now you don't know why I have drawn it like this, like an equilateral triangle. Why did I not draw it like this? I could have drawn it like this also, no? But I didn't draw it like this. So why did we not do that? So Lewis has no idea about bond angles. Lewis has no idea about, okay, Lewis has no idea about what are the bond angles, what are the bond lengths, where exactly the geometry should be. All these things will be done in the next class. Okay. Thank you, Dhanlakshmi. Bye bye. See you all in the next class. Tomorrow I'll meet you. Please revise it and come. Hybridization tomorrow. Yes, hybridization tomorrow.